Notes on 2.3 are on the topic of triangle congruence. Here we have two triangles shown, and we are given that triangle ABC is congruent to triangle FDE. What that sentence means is that angle A is congruent to angle F. So you can mark the diagram, and I'm going to write angle A is congruent to angle F. Next, angle B is congruent to angle D. And third, angle C is congruent to angle E. There are three other pieces of information we can get from that sentence. There is segment AB congruent to segment FD, segment BC congruent to segment DE, and then segment AC congruent to segment FE. You can mark those congruent as well. Number 1, angle A is congruent to what corresponding angle? Number 2, CB is congruent to what corresponding side? Number 3, FE is congruent to what corresponding side? Congruence means that two items have the same size and the same shape. We are given triangle ABC is congruent to triangle DEF. Please write the 6 things that follow from that sentence. The drawing is here to help you. Pause the video and write the 6 different congruent statements, and then turn the video back on to check your answers. Next, we're going to practice working on this backwards. When we were given a congruent statement for triangles congruent, we were able to come up with 6 different congruence sentences from that one congruent statement. Now we're going to turn that around. We want to come up with a triangle congruent statement for these pictures below. And in order to show that two triangles are congruent, we're only going to need 3 of these statements, not all 6 of them. But we're going to need particular combinations of 3. So it's not like you can have any 3 of those sentences. We'll start with the easiest one first. The first drawing here has an SSS above it. Those 3 S's stand for side, side, side. This method says that if you have 3 sides of one triangle congruent to 3 sides of another triangle, then the triangles are congruent. So what is meant is if you have 3 sides congruent. So I'll write that out. If these 3 things are congruent, then you can say that triangles are congruent. The first triangle is named DEF. You could call it EFD or FDE or FED. You can choose how to write that first triangle's name. After that, though, it matters how you set up the second name. So which vertex should I start writing? Well, I'm going to go back and look at triangle DEF. If I start at point D and go to E, I'll be going down the side with 3 tick marks. Then I'm going to go to F. So that means I'd be going down the side with 2 tick marks. Then do the same thing on the other triangle. So where would I start so that I would go down the side with 3 tick marks, followed by going down the side with 2 tick marks without lifting my pencil up? So I would start at point I and go down the side with 3 tick marks. So then next I would go down the side with 2 tick marks. The order of the letters for the second triangle is IGH. Next method is SAS. That stands for side, angle, side. This one requires a little more thinking because the angle that we use has to be found between the congruent sides. Notice how angle A is congruent to angle R. And then notice how A is in between the congruent sides. Same thing in the other triangle. Angle R is found in between the congruent sides. As long as I have these three things in the order of side, angle, side, I can say the triangles are congruent. So the first triangle goes side, angle, side. The second triangle goes side, angle, side. If we get these three pieces of information, we get side AC congruent to QR. Then angle A is congruent to angle R. And finally, side AB is congruent to side RS. Once you have those three, then you can say the triangles are congruent. I'll use the name for the first triangle as CAB. The second triangle has to correspond. When I walked the sides of CAB, I started at C, I went down the side with 2 marks, then I went down the side with 1 mark. So do that on the other triangle. Start at Q, which will take you down the side with 2 marks, and then across the side with 1 mark. So the other triangle should be called QRS. The third method is angle side angle. This one too has a requirement that the side is between the 2 angles. When the side is between the 2 angles, it's called the included side. Notice how in the first triangle, angle A and angle B are here and the side is in between them. And then in the second triangle, here's angle X, here's angle Y, and the side is in between them. So make sure the congruent side is between the congruent angles. Let's set up our 3 congruence statements. If you have those 3 things, then you can say the triangles are congruent. You can call the first triangle anything you want. I'll just call it ABC. Then it matters how I write the second triangle. A is with the double arc, then I go to B with the single arc, and then I go to C. So I'll do the same thing in the other triangle. I start at the double arc, go to the single arc, and then go to Z. The order of the letters should be X, Y, Z. In the last method, the diagram isn't correct, so I'm going to remove the tick mark off of this side ST. I actually want the tick mark on side TU. Angle, angle, side has an angle. Then when you go around the triangle, then there's another angle congruent, and then there's a side. I'll do that on the other triangle. Notice if I start at angle S and I go around the triangle, the next thing I encounter is angle U, which was congruent to K, and then side TU. It went in the order of angle, angle, side. Angle, angle, side postulate. New property we're going to learn is reflexive property. This property is used when a figure is congruent to itself. So what we say is that an angle is congruent to itself, or we will say that a segment is congruent to itself. In the first picture, we have what is a triangle within a triangle. I want you to look down at this angle right here, angle Z. Wouldn't you say that angle Z is an angle of triangle XYZ? At the same time, it is an angle in triangle ABC. So this is a situation where we might say angle Z is congruent to itself. Or you can say angle XZY is congruent to angle AZB. And then everyone would know that you're referring to the 2 different triangles when you do that. We can do the same thing with a segment. Look at the picture to the right. Down the middle of that triangle is a segment XZ. It's dividing the triangle into 2 smaller triangles. There's a triangle on the left and a triangle on the right. Notice how segment XZ is a side of the left triangle and it is a side of the right triangle. So we will often use xz is congruent to xz as one of our three statements to prove triangles congruent. So you remember from the previous page, I'm going to scroll back to the previous page. We needed 3 sentences before we could say triangles congruent. Over here I have 3 sentences before I could say triangles congruent. So what's going to happen is we're going to use this reflexive property to get one of those 3 sentences. Let's practice reflexive property for a moment, and then we're going to have to give congruency statements and reasons if the triangles are congruent. So a congruent statement is the kind of thing we were writing on the previous page when we wrote triangle ABC is congruent to triangle DEF. That's a congruent statement. And then our reasons are going to be our methods. We learned 4 methods on the last page. They were side, 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 angle, side, angle, side, angle, and angle, angle, side. In number 1, we have 2 pairs of congruent sides. You can see that AD is congruent to CD, and then AB is congruent to BC. Well, we do have a third congruent side. It's the one that the triangles share. The top triangle has BD as a side, and the bottom triangle has BD as a side. So these triangles will be congruent with the help of reflexive property. So since they will be congruent, I'm going to write a congruent statement. The name of the top triangle I could write as ABD. Now I have to correspond my letters for the bottom triangle. Well, angle A corresponds to angle C, so it will go CBD. And the method that would prove these triangles congruent is side, side, side. Number 2, they only gave me 1 pair of congruent segments, but I could get a pair of congruent angles because right here I have vertical angles congruent. But that's only 2 things. I need 3 congruences before I can say the triangles are congruent. So I'm going to have to write the word none. Number 3, I have 2 sides congruent and the included angle. So this one looks good already for congruent triangles because of side, angle, side. Now I chose ABC as the name, so that's A going down the line with 1 tick mark, going across the side with no tick marks. So doing that on the other triangle, I would start at R to go down the side with 1 tick mark, and then down the side, no tick marks. So the order would be R, S, Q. Number 4, there are just 1 pair of congruent angles shown here, but notice what else has shown up. We have parallel marks on these sides. That means RQ can act like a transversal, and that gives me alternate interior angles congruent. So I can conclude those angles are congruent. I also have reflexive property in the middle of this shape. So notice this. I can go from angle R, that's an angle, to this side, to this angle. So it looks like I have angle, side, angle. Can you do that on the bottom triangle? Start at the blue angle, so you have angle, side, angle. So our method to prove triangles congruent here is angle, side, angle. And the name of the top triangle I could call RPQ. RPQ, that goes from the blue angle over to P, over to the double arc angle. So I'm going to do that on the bottom. Start at the blue angle, go across S, and end up at the double arc angle. The name of the bottom triangle would be QSR to create that correspondence. Number 5, the diagram for the first triangle has the congruent angle between the congruent sides, so it's included. But look at the second triangle. That angle is not in between the congruent sides, so this one is going to be none. Number 6, we get 2 pairs of congruent sides, but we don't have a third sentence. We either needed like angle F congruent to angle Q, or we needed side EG congruent to side PR. But we have neither of those. So this one is none also. Identify the additional congruent parts necessary to prove the triangle's congruent by the given information. So given this diagram here, I only have two congruent statements. I have this side congruent to this side, and I have this angle congruent to this angle. That's only two things. To prove triangles congruent by angle side angle, I need another angle. So where's that angle going to be? Well, first I'm going to put my pencil on angle C. So I'm going to go from C to side BC, which then takes me to angle B. So I would need angle B to be congruent. Now look at the other triangle. Angle, side, angle. So that other angle is going to be angle D. Okay, let's erase those arrows. The next question asks me to determine what do I want congruent in order to achieve side, angle, side. Well, I'm going to change the direction that I walk around the triangle. I'm going to go to this side. Then I already have this angle. So that means I would need this side. So I would need side AC congruent to side, angle, side. I need it to be congruent to FE. Then I can say that the triangles are congruent. Okay, last one. I want to prove triangles congruent by angle, angle, side. So in order to have angle, angle, side, that first angle needs to be here, because angle A, and then move to the right, angle C, and then a side. So you're going angle, angle, side. So angle A needs to be congruent to angle F in order to prove triangles congruent by angle, angle, side. Now you take a turn. Pause the video, try numbers 1 through 4, and then turn the video back on to check your answers. Number 1, you can conclude that vertical angles are congruent to get started. That's not enough information. We need a third piece of information, and that would be another angle, because we want angle, angle, side. So if I look at this angle and I want to get over to that side, I can go this way, and then I can hit that side. So I'll go angle, angle, side. You can go in that direction, or you can go down. That's another option. But in this direction, I would need angle G congruent, and then go back up in this direction on this triangle. I would need it congruent to angle K. If you want to, you could instead go down to this angle. So you'd be at angle, angle, side. Then we'd have to go down over here, angle, angle, side. So another option is to get H congruent to angle J. You have two options there. Number 2, this is side, side, side we're looking for. So that means I would want this side congruent to this side in order to use side, side, side. So the answer is BE congruent to BD. Number 3, side, angle, side. Notice the angles this time, they're right angles, and we know right angles are congruent. So I want to go from, since I want side, angle, side, I'm going to go down this side to head toward this angle. So the other side I want is past that right angle. So I want SU. And then I'll do the same thing on the other triangle. I want to go down this congruent side, hit that right angle. So the side I want is FH. So we would want SU congruent to FH. And then for the last one, angle, side, angle. So start at the congruent angle we already have, go down the congruent side we already have, and that takes us to angle T. On the other triangle, I'll start at the right angle, go down the congruent side, and that takes me to angle G. So that's angle T is congruent to angle G. If they give us that piece of information, then we can prove the triangle is congruent. Please pause the video and try the closure, then turn the video back on to check your answer. Number 1, we know XT bisects SR, so mark the diagram so segments are congruent. We also know that XT is perpendicular to SR. Therefore, we have two right angles at the base here. The third thing we could do is reflexive property on segment XT. So that gets our third and final sentence that we need. We know that ST is congruent to TR. We know that the right angles are congruent. congruent. XTS is a right angle. It's congruent to XTR. And then by reflexive property, TX is congruent to itself. So that means these triangles are congruent. So XTS, the triangle on the top, is congruent to XTR, the triangle on the bottom. And the method by which I'm showing this is side angle side. Number 2, I know that vertical angles are congruent, so I can mark those angles congruent. And now I have 3 pieces of information. They gave me angle A is congruent to angle B, and they gave me AE is congruent to BE. So the vertical angles are CEB is congruent to angle DEA. And so by angle side angle, I can say that the triangles are congruent. The top triangle, I'll call it BEC. And I did that because B has a mark on it, 1 arc, and then E has a mark that's 2 arcs. So on the other triangle, I'm going to go down to angle A. That has 1 mark. So the first letter is A. It corresponds to B. And then I'll go to E because it has 2 marks. And then the last letter is D.